These are electricity example problems, number 5, 6, 7. So there are 3 of them here. The side mirror in Bryce's car has a resistance of 4 ohms. So here's a good example of a heated mirror. You can tell it's heated because of this little sign that you see here that just shows that it's heated. So the resistance for this heated mirror is about 4 ohms. And they said that the lighter can draw about 12 volts. So we'll go ahead and put 12 volts on here. And they want to know how much current runs through it. We're going to go back and use Ohm's law again. We know that V is equal to I times R. So we'll plug everything in. 12 volts is equal to our current times the resistance, which is 4. And divide both sides by 4. We'll see that our current is equal to 3 amps. For part B, the next thing they want us to find out is how much power does the lighter use? And the equation for power is pretty easy. It's just P is equal to IV. If you've ever had an IV in your arm, you know it's pretty painful, so they always say P is equal to IV. The current we solved earlier is 3 amps, and then if you remember, our voltage from up above was 12 volts. If you multiply the two together, you end up with our final answer, which would be 36. And then the unit for power is called the watt, and plural would be watts. For number 6, which is the next example, you have a young lady. Her name is Carol. She is in her dorm room. She has her iron, which you see here, plugged into the outlet. And we know that the voltage coming out of that outlet is 120 volts, so that's the push. It also says that the circuit breaker in the dorm has a current load of about 5 amps, which means it's a lot smaller than what you would have in your house. If she tries to iron her blouse for class with her 700 watt iron, so we know that the power of this iron is about 700 watts, they want to know, will she trip the circuit breaker? So the thing that we're going to solve for first is going to be for current. They gave us a current for reference, and they said that we can't have current any bigger than 5 amps. So let's go ahead and try to solve for this. Remember, we know that power is equal to current times voltage. So if I want to solve for current, that's going to be equal to power divided by voltage. Our power is 700 watts, and we know our voltage is 120. So if I divide the two, we end up with 5.83 amps, which means that yes, she will trip the circuit. She'll have to stop ironing and go fix that. For part B, they want us to try to figure out what is the resistance for that iron. So for the iron, we know that the voltage was 120, so we still have that up here. We know that our current is 5.83 amps. So let's go through and see if we can find out what the resistance of the iron is. We know from Ohm's law, V is equal to I times R. So if I want the resistance, I can rearrange my equation, divide both sides by I, and I get V over I. Our voltage here is 120 volts. We know that our current was 5.83 amps. And if you do your math, you'll end up with 20.5. Lots of people want to put volts over amps. Remember, resistance is measured in ohms, so it'd be 20.5 ohms. For the very last question, this one deals with how much it costs to run a light. So we see in the picture over here on the side, this is the Garcia's home, and they love to run their porch light at night to welcome friends as they come in. So they turn on the porch light at about 6 p.m. and they let it run all the way until 7 a.m. So notice here that this is not 11 hours. This is actually 13 hours. So we know that this is running for 13 hours. The other thing they tell us is they tell us the power here is about 40 watts for that light bulb, and that the cost for the electricity is 8 cents per kilowatt hour. And notice that the kilowatt hour is not kilowatt per hour, but it's a kilowatt times an hour. The first thing we need to do is we need to convert our power from watts to kilowatts. So when you deal with money and electricity, we want everything in kilowatts. So we're going to divide this by 1,000 watts in a kilowatt. So 40 divided by 1,000 will be 0.04 kilowatts. They want us to go through, we know that if we go 13 hours, they want to know how much it is for a week. So we're going to take 13 hours and we're going to multiply it times 7 days. And when we get done, we should know that that's about 91 hours. At this point, we need to figure out what is the amount of energy or work. Remember, in electricity, we interchange those two, and we say that's just power times time, or the change in time. The power is 0.04 kilowatts, and we need to multiply that times the number of hours that it's run, and that's 91 hours. And our unit then we can see is a kilowatt hour, so if I multiply the two together, I get 3.64 kilowatt hours. Now we can figure out the cost. We know that it's about 8 cents for every kilowatt hour, and we can multiply that times the number of kilowatt hours, which is 3.64 kilowatt hours. And if you do your math correctly, you should end up with 29.1 cents. So it doesn't cost very much. If you multiply that out for a year, you'd see to run that light every night for 7 hours all year long would cost you no more than about $15.